LEA.4 is asking you to interpret the graph. So we have an equation that we've been given where the population, which is represented by this side here, is equal to 5,000, which is your initial population, times 2 to the power of h. And h represents hours. And then this is a graph of the function p, where p is the population in thousands. So remember, on your x-axis, x is always the time. So this would represent the hours, and p, this would be your population. And so this is in thousands, which means that this is really 200,000, 150,000, 100,000, and 50,000. So when it says use the graph to determine when the population will reach 100,000, what you're looking for is where the population is 100,000. So 100, you follow it over, where does it hit the graph? And then when you follow it down, this would be approximately how many hours it would take for that bacteria population to reach 100,000. On the second part, it's asking why log base 2 of 20 also tells us when the population will reach 100,000. So that's basically just asking us to solve that equation and verify what we learned from the graph. So 100,000 is our population. This represents our population, so we're substituting 100,000 in for the population, 5,000 times 2 to the power of h. So remember, when we solve these equations, the first thing that we want to do, we're trying to get h by itself. So the first thing that we need to do is we need to divide by 5,000. And same thing over here, divide by 5,000. So we have 100 divided by 5, which is 20. And then we have 2 to the power of h. So in order to rewrite this so that h is by itself, we're going to rewrite this as a log. So we have log base 2 of 20, and whatever we do to one side, we have to do to the other. And we're using log base 2 because the base of our exponent is 2. So these are going to cancel each other out, and so h would also be equal to log base 2 of 20.